In this session, we will discuss the seqinfo part of GRanges objects. You've seen seqinfo. You've seen that it contains information about the length and the names of the chromosomes. And it's mundane to spend some time talking about how to manipulate the seqinfo, but in practice, it's something that we do again and again, and it pays to be on top of it. Now, one of the first things you do when you deal with let's say weird seqinfo slots is that you try to get rid of some of the chromosomes. This is very common, even for analysis. You may restrict your analysis to the sex chromosomes or the autosomes, or you may, for convenience, just want to look at chromosome 22, which is the smallest chromosome. So let's look at how we do that. So let's make a GRanges with 2 chromosomes. You can do this using various functions. One way is you use seq levels and you use the force argument to seq levels. This looks a little weird, but it works well, and you see it used again and again in other people's code. You say force equals true, and now you give it a list of chromosomes that you want to keep. So in this case here, we have now dropped everything on chromosome 2, or everything that's not chromosome 1 from the object. Let's recreate the object, and inside a package called GenomicRanges, which is automatically loaded when you load GenomicRanges, there's a set of functions for manipulating and dealing with seq levels. So there's 2 convenience functions: drop seq levels and keep seq levels. They do exactly what you would expect. You say drop seq levels, gr, and now you want to drop, let's say we want to drop chromosome 2. We get something back where we have dropped chromosome 2. In the same way, we can keep a set of seq levels. In order to get the same result, I want to keep chromosome 1, which is the same as dropping chromosome 2, and I get the same thing. There's also support for dropping weirdly looking chromosome names. So let's take a weirdly looking chromosome name, which are usually, for some organisms, small contigs. So here we are really talking about small contigs from a well-assembled genome. There's a function called keep standard chromosomes. And, basically it keeps the standard-looking chromosomes. What exactly is a standard-looking chromosome takes a little while getting used to, and I would encourage you to just run it and see what comes out of it. Now, it's also a sad truth that chromosome names is a pain in the butt at times. Different sources and different data sets lying around on the internet use different chromosome styles. So some call them chromosome 1, some call them chromosome 01 for sorting, some call them chromosome capital 1, some call them just 1 or just capital I, and there's a lot of different styles. And these different styles depend on different sources, and they can also be different from organism to organism. In GenomicRanges, there's functionality for quickly converting between different styles. That's convenient. Say you're doing an analysis where you get data from a lot of different sources, and you want to make sure they all use the same chromosome names, and you want to use the same styling from the chromosome names. So let's go back here and have our example thing where we have chromosome 1 and chromosome 2 inside of GRanges. And the way you do this using GenomicRanges is you set up first a vector of new styles, where you say map, seq levels, gr, and then you have to give it the style name. And this here, let's use NCBI style. Oh, it's not the gr, it's the seq levels. And this here converts from chromosome 1 to the NCBI style. Let's look at what it looks like. Well, it's a very simple vector here. It converts chromosome 1 into 1 and chromosome 2 into 2. And the way we now rename the thing is we say our GRanges is equal to the rename seq levels gr, new style. I think, oh, else would I, if I can spell. And now I have a harmonized with NCBI style of seq names. Sometimes this can go wrong if you have weirdly looking chromosomes, or there's some chromosomes that have entered in wrongly, and then you can like examine the thing that you can examine this new style vector and see whether or not it looks sensible. In the future, we hope that it will be as easy to harmonize sequence lengths, which is something we often want in our objects as well. Currently, the best way of doing that is the easiest way is probably grabbing the sequence lengths from the different BS genome packages, where you can do a seqinfo on a BS genome package or BS genome object, and you get back kind of genome level information that's ready to put into your GRanges.